Hi and welcome back to my channel. This week's problem is trying to find the radius of the red circle in this diagram. And on the diagram we've got a rectangle which has got a red circle contained inside of it, and in between the outside of this green rectangle and the larger yellow circle. Now the other thing that we need to note is the green rectangle has an area of 15, and that will be useful later on. So bear that in mind, remember that, because I will come back to that later on. We will need that bit of information. Now, if you want to have a go at this problem for yourself, pause the video now, because I'm going to go through my solution in 3, 2, 1. Okay, let's get stuck into it. So the first thing I want to do is I'm going to just tidy the diagram up a bit. So I'm going to get rid of the question mark, get rid of the 15, but like I say, remember that 15 for later. Okay. Now, the next thing I'm going to do is I'm going to start labeling some of these things. So I'm going to label the center of the yellow circle O, and then the corners that I need of my green rectangle A, B, and C. And then I'm going to introduce a radius. So the radius of a yellow circle that goes through the pink or red circle. And I'm going to label that as 2R. That's 2R is the radius, well, the diameter of the red or pink circle. And then we've got to add a little bit extra on, so we're going to call that X for the radius of the yellow circle. Now, what we have got there is a right angle, okay, because a tangent meets a circle at, well, makes an angle of 90 degrees with the radius, so we've got a right angle there. And then we've got the length of the rectangle, which we're going to call y. I'm going to split that up into y for half of it, so 2y in total. And then I'm going to label the part where the red circle touches the green rectangle as D, as you can see there. Triangle ADO is similar to triangle ABC because the angle at A is a shared angle. They've both got right angles in, one at D and one at B, and therefore the third angle must be the same, and therefore they are similar. Now I'm going to draw out those similar triangles like this, and I've labelled them. Now hopefully you can see the scale factor there is 2, and so the length B to C must be double X times that by 2 is 2x. So I've put that on the diagram as well. Now, the next thing I'm going to put onto my diagram is the radius of the yellow circle is 2r plus x. Now, we already knew that because we already had a radius going from O through the pink circle with 2r, and then we added the x on. Now, what we've got there is we've got Pythagoras, and the area of the rectangle gives us two equations. So Pythagoras gives us equation 1, and then the area of the rectangle, I said we come back to that, is 15. That is equation 2. Now, the next equation, and we need 3 equations here because we've got 3 variables, is a little bit trickier to find. The next equation comes from, well, where I'm going, what I'm going to show you now. So I'm going to introduce the radius, so I'm going to draw on the radii from the other pink circle, not as I said triangle then, pink circle that I haven't really talked about too much so far. Now, they obviously will all have a radius of r. We've got right angles in all 4 of those corners, one because of the triangle in the rectangle, and then again, like we had earlier, a tangent meets a radius at 90 degrees, and so the 4th angle must also be a right angle, which means we've got a square, and so we can label these R as well. Now, the key thing to note here is, and I need to do some extra labeling here, E, F, and G, is that the 3 sides, these 3 sides, or 6 sides, but 3 pairs of sides must be equal. And that is all to do with the fact that we've got these like kite shapes that we've now made using the radii. So A to E must be equal to A to G. Now the reason that is because if I drew a line from A to the center of that pink circle, which I haven't labeled, but if I did do that, then we would have, again, identical triangles, congruent triangles. We'd have the same right angle, we'd have the same hypotenuse, and they would share a side in R, and so the third side must also be equal. So therefore, they must be congruent triangles, they must be the same. Now that means, therefore, that the other side, like we've said, must be the same. A to G must be the same as A to E. Now that logic works for all three of these kites. Well, one of them's a square, but like I say, it also would work for F to C is equal to G to C, and like we've already said, E to B must be equal to B to F because it's a square. Now, what that therefore means, it gives us our third equation. 2R, those two R's from E to B and B to F, we can get those by doing A to B, which is 2Y, plus B to C, which is 2X, and then subtract A to C, which is 2 lots of 2R plus X, because that will cancel out some of the sides and just leave you with the 2R, leave you with E to B and B to F. Right. Now from there we've got our three equations. It's just about manipulating these now to get things that we can substitute into each one, and therefore then our final answer. So equation 3 is the one I'm going to start with because that's just quite nice really. I'm going to rearrange that, I'm going to simplify it, and I'm going to get 6R equals 2Y, and then 3R is equal to Y. Okay. What I'm going to do with that, I'm going to substitute that now into the first equation. Okay, we get this, and that will simplify to 9R squared equals 4R squared plus 4RX, giving us 5R squared is equal to 4RX, and then 5 over 4R is equal to X. Now, at this point, we are very close to finishing and finding out what R is. We're going to substitute both of these from equation 1 and 3 into equation 2, and that will give us 15R squared equals 15. So it's pretty obvious at this point, R squared is equal to 1, and therefore R, well, technically could be plus or minus 1, but we can't have negative 1 because the radius is a length. It has to be positive, so R is equal to 1. What a nice and neat solution, a nice and neat answer that we get there. Hopefully you enjoyed that solution, that problem. If you had a go at it yourself and you got the same answer and you did it a different way, please put it down in the comments. I always enjoy reading your comments. And if you, like I say, if you enjoyed the video, please drop a like on the video and consider subscribing to the channel, because I put a new video up every Monday with a new problem that I go through and show you my solution. Okay, like I said, I hope you enjoyed it, and thank you for watching. I will see you next week for another video. Till then, bye-bye.